Hello everyone, my name is Shambhavi. Hope you all are doing well. So we were learning about the different terminologies in the probability, right? Further what I will be taking you through is that I'll be taking you through calculating up the probability of an event where all the outcomes in the sample space are equally likely. If you remember and if you did have watched up my previous video, so onto that, the last topic which we discussed was equally likely, right? We were dealing with that. What is this equally likely actually, right? And further, I'll be taking up today's video from this respective topic only. So equally likely means that each outcome of an experiment occurs up with the equal probability. Okay, that each outcome of an experiment occurs up with the equal probability. This is what equally likely actually meant out. Okay. Now if I have to compute up the probability for that, so how will I be doing? So let's check that out here. So let me put that out. So, oh, I am so sorry. Let me just take the thin pen. Fine here. So it is to calculate the probability, probability, B-I-L-I-T-Y, okay? Huh. So to calculate the probability of an event, A. Let's say that my event is actually A, okay? So for calculating up the probability of an event A, when all outcomes in the sample space are equally likely. Okay, when all the outcomes in the sample space are equally likely. Okay, are equally likely to count the number of outcomes for event A and divide by the total number of outcomes in the sample space. Okay, pretty fine. So to calculate up the probability of an event A where all the outcomes in the sample space are equally likely, to count the number of outcomes for event A and divide by the total number of outcomes in the sample space. Okay. So onto that respective case, this is how you calculate out the probability of an event. Okay, when the outcomes in the sample space are equally likely. Okay, now let me just quickly take up an example here. So let me just get down from this particular place. Fine. So my example like this goes. My example goes in a way that, let's say, if you so if you toss a fair dime and a fair nickel. Okay, if you toss up a fair dime and a fair nickel, the sample space, or you can say a coin. Okay, so the sample space is, what's my sample space? So that will be head, comma, tail, head, tail, tail, right? This is the sample space if you toss up the coins, right? This is the sample space which occurs about. Now into this case, this will be a sample space if you like toss two coins simultaneously. So this will be sample space, right? Now where, into this question only, where T is my tails, where T is equal to tails, and H is equal to heads. Okay, where T is equal to tails and H is equal to heads. Okay. Now into this respective case, so the sample space is having four outcomes. Right, in this we are having the sample space. The sample space has four outcomes. Okay, the sample space has four outcomes. So what will be my A? Right, the we just took above that if we toss a fair diamond and a fair nickel, the sample space is head, tail, head, tail, and tail, right? Where T refers to my tails and H refers to my heads. Right, so the sample space has this respective sample, the space is having a four outcomes in total. Right. So further, I'll be having up there that the A, that's my probability. So it's equal to getting one hit. So I have to compute up the probability for getting up the one hit. So there are in total two outcomes which are having hits, right? Which are having one hit. There are in total two outcomes. So I would write that there are two outcomes. There are two outcomes. First is my head tail and second is my tail head. These are my two outcomes, right? So into that case, I'm going to write up that the probability of A is equal to 2 by 4 because in total we were having four outcomes, and from that four outcomes we were having two outcomes which are having one hit. Okay, so for that we were having these two outcomes, so head tail and tail head. So in total I have the 2 by 4. So 1 second, here it is. So 2 by 4, it's equal to 1 by 2 and that's equal to 0.5. And remember I told in my previous video that the probability, if the probability of A is equal to 0.5. So into that case, we say that the event is equally likely to occur or not to occur. If you remember, let me just take to you at that particular position. Yeah. So here I told in the previous video that if the probability of A is equal to 0.5, it means the event A is equally likely to occur or not to occur. And see here what I am getting probability of A is equal to 0.5. Right, so this is how you calculate up the probability of an event for all the outcomes in the sample space which are equally likely. Okay, so hope I'm pretty much clear with this particular thing too. Great. Fine, pretty fine. Now this is how you approach up the questions into this respective manner. Simply whatever the question was given, I was given that this die has been rolled. So two simultaneous die have been rolled. So I simply put up the things for those only. Further, we have to write up all the sample spaces which occurred or which will be occurring. So it was head tail, tail head, and tail tail. Right, these are the only four outcomes which could occur if the coin is tossed. Further, T was referring to my tails and H was referring to my heads. Right, so into that case, the sample space will actually have the four outcomes, right? And A will be that getting one head. So in that case, there will be now two outcomes, right? That is head tail and tail head, because these are the only two outcomes in which head is occurring. One head is occurring, right? These two are the only events. So I just wrote up both of those, and then the probability of A is 2 by 4, that is equal to, if I cancel that out, so it's equal to 1 by 2. Further I have 0.5 and the probability of A is 0.5, so that means that it is likely actually to occur, right? It is equally likely to happen, right? So this was what we just discussed about as well. Right, so hope I am pretty much clear with this particular thing to you regards of this respective example which I did have taken up here. Right, now what I want to do is that I want to just revise up these terminologies once for you, because it will be very much easier for you to relate up with the things and to get up the things here. Okay. So we started up here that what's up an experiment, right? So what is that? It is a planned operation which is carried out under the controlled conditions. Okay, if a result is not predetermined, so then we see that the experiment is said to be a chance experiment. Okay, if the result is not predetermined. So in that case, we say that the experiment is said to be a chance experiment. Okay, what we meant out by outcome, so that is the result of an experiment. Okay, the result of an experiment is called an outcome. Fine. What is a sample space? So a sample space is a set of all possible outcomes. Like, so whatever the possible outcomes are there, so it is a set of all of the possible outcomes, sample space, right? And how you denote that out? So that is denoted using the capital S. So capital S is used to denote the sample space. Okay, right. Yes, further we discussed about the event, that what is an event. So an event is a combination of the outcomes, right? So A and B represent the events, that is probability of A. If you want to write that in the form of probability as well, so it is probability of A like this. So what are the uppercase characters you are having? Those all represents up the events for you, right? Now, the probability of an outcome is a long-term relative frequency of that outcome, right? Now, if the probability of A is 0, is equal to 0, it means that the event can never happen up. Okay. If the probability of A is equal to 1, so it means that the event A always happen. And if the probability of A is equal to 0.5, so it means that the event A is equally likely to occur or not to occur. Fine. So equally likely means that each outcome of an experiment occurs with equal probability. Okay. So to calculate the probability of an event A when all outcomes in the sample space are equally likely to count the number of outcomes for event A and divide by the total number of outcomes in that respective sample space, right? And for that, we just took away, see up an example that how do we compute the probability of an event when the outcomes in the sample space are equally likely. Right, so hope I am pretty much clear with this particular question to you, that how to solve a problem. That was a quick, very easy problem. I hope that's pretty much clear. Further, we'll be having some difficult problems as well to solve about and to look at how to deal with some multiple type of problems, some difficult problems, right? So this is all for this video. Till then, thank you and take care.